Now we're going to use a pencil to find the inverse, if it exists, of this matrix here. Here's how we do this. Here's our setup. I'm going to draw this matrix here, 2, -4, -1, and 2. Put a vertical line, and then on this side here, I'm going to put that identity matrix, the 2 by 2 identity matrix. And then the idea is ... use a bunch of row operations, and then convert the left side to 1, 0, 0, 1. Right, so I'm going to do some work here. I'm going to convert this side over here to this, and whatever I get over here, that's now going to be the inverse. So let's give it a try. First up, let's get rid of this and do our actual work here. So I'm going to start here with trying to get a 1 in this position. So I can get a 1 in this position, right, as my pivot element if I just divide by 2. So row 1 will become row 1 divided by 2. And that is going to look like this. So just divide every element in that first row by 2. It'll be 1, -2, 1/2, 0. Row 2 stays the same. -1, 2, 0, 1. Now I need a 0 in this position. So I know what to do. I'm going to change row 2. So row 2 will become, and you know the process, right? Take the opposite of that number. This is -1. The opposite is 1, and multiply it through our pivot row. So there's my pivot. So I'm going to multiply the opposite of that, which is 1, times row 1, and I'm going to add row 2. And it looks like this. All right, I'm taking a 1, just multiplying it through here. So I'm not really changing it, right? I'm just multiplying by 1. So it's going to be 1, -2, 1/2, and 0. And then I'm going to add that to that row right there. So row 1 stays the same. So that's going to be 1, -2, 1/2, and 0. And then when I add the current row 2 to the new row 2, what's going to happen? -1 and 1 is 0. 2 and -2 is 0. We're going to use a pencil to find the inverse of this matrix, should that inverse exist. Here's how we do this. We're going to write our matrix right here, draw a line, and then we're going to write that 2 by 2 identity matrix. Right, this is matrix I. Now the idea is to use some row operations and change the left side to the identity, and the right side then will become the inverse. That's the plan. So let's try it. Let's erase this and actually start it here. So what I want is a 1 in that position. So I'm going to divide this whole row by 2. So here's the plan. Row 1 is going to become the current row 1 divided by 2. So here's what we're going to get as our new row 1. We'll get 1, 3/2, line, 1/2, and 0. Second row stays the same. -4, -7, 0, and 1. Now this element here, that 1, that's our pivot element. I'm going to circle it, and then I'm going to use that pivot and that row right there to change that -4 to a 0. So I'm on a 0 here, and I know the process. I take the opposite of that number, multiply it through the pivot row. So what we're going to get here is row 2 is going to become the opposite of negative is 4 times the pivot row, row 1, and then I'm going to add that to row 2. And here's what it looks like. So multiply everything in that top row by 4. We'll get a 4. Now 4 times 3/2, that's 12/2, which is 6. 12 times a half, 4 times a half is 2. 4 times 0 is 0. There we are. I'm going to add that to row 2. So here's where we are now up at the top here. First row stays the same, 1, 3/2, our line, and 1/2 and 0. And then let's add component-wise the current row 2 to the new row 2. -4 plus 4 is a 0. Then we have a -7 and a 6. That's a -1. And then a 0 and a 2, that'll just give us a 2. And then finally the 1 and the 0 is a 1. We're close. We need a 1 here, right? I've got the 1 in the zeros. I need a 1 on that diagonal. So how about if we do this? Row 2 will get replaced by negative 1 times row 2, right? So just multiply everything in row 2 by a negative. We'll have this new matrix. We will have row 1 is the same, 1, 3 halves, line, 1 half, and 0. And change all the signs. 0, 1, negative 2, negative 1. And there is our new pivot element. And I'm going to use that pivot element with that row right there to convert that 3 halves to a 0. So I know how it works. I take the opposite of that number, negative 3 halves, and multiply it through that pivot row. So row 1 is going to become the opposite number, 3 halves, times row 2, right, the pivot row, plus row 1. Now let's see what this looks like. What is negative 3 halves? Right, so take negative 3 halves and multiply it here, 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 and here. So negative 3 halves times 0, that's just 0. Negative 3 halves times 1, that's just negative 3 halves. Then negative 3 halves times negative 2. Well, negative negative is positive. 3 times 2 is 6 over 2 is 3, so we'll get a positive 3. And then negative 3 halves times negative 1 is positive 3 halves. All right, I'll circle that, and then we're going to add that to row 1. Here we are. So row 1, the new row 1 is the current row 1 added to this one. So component-wise, first plus first, 1 and 0 is a 1. Then second and second, 3 halves minus 3 halves, that's a 0. There's our line. And then 1 half and 3, well, that's 3 and a half, or how about 7 halves? I'll write it as 7 halves. So I'm going to write it as 7 halves. And then we'll have 0 and 3 halves is 3 halves. Second row stays the same. 0, 1, negative 2, negative 1. All right, so here's the identity, the 2 by 2 identity, and here is the inverse. So I'm going to say, here's how I'm going to write this. Here's our original matrix, 2, 3, negative 4, negative 7. The inverse of this is equal to this new matrix, 7 halves, 3 halves, negative 2, negative 1. Now just an alert on this notation. This is not like this, all right? This is not x to the negative 1 is 1 over x, all right? It's not like that. It's more like this. Remember f to the negative 1, that was f inverse? All right, so that's just the inverse notation.